we've figured out where it's increasing, decreasing, right? We had on the last test, functions increasing, decreasing. Where there's relative extrema, maximum minimums, right? We did that. Intervals of concave up, concave down. We did in the last chapter, right? Coordinate of points of inflection, where it changes from concave up to concave down or vice versa, right? All of those things we've done before. That's nothing new, okay? The difference today is the type of information they're giving you is different, right? They're not giving you an equation. They're not saying, okay, well, for that equation there for f of x, tell me all of those things. You did that. That was last chapter, okay? This chapter, they're saying, there it is. Tell me all of those things. That is the equation. Say, it's a graph, right? So we have to be able to tell things from the graph. All of those things, critical points, relative extrema. Like if you go through all of these things, you're going to see a lot of that you see for. Critical points for f of x, relative extrema for f of x, maximum minimums, increasing, decreasing, points of inflection. I mean, really, I'm just picking off words, concave up, concave down, that you did on your last test, right? All of that stuff you guys have done on your last test. The information they give is different. They're not giving equations anymore. They're giving you graphs, okay? So when you're doing this, it's not a lot of work, but it's a lot of thinking, okay? So in this year, the students that do the best are the ones that don't mind thinking, using critical thinking. If you go to the first day we were in class, and I gave you the syllabus. I'm like, here's the syllabus. First sentence of what this class is about, there were 2 words: critical thinking. Critical thinking. Because of stuff like this, right? Like this. So that's the thing. There's not a lot of calculations today. We're not going to do a lot of calculations like we've done in the past, right? Like we did, like there were some problems that, I mean, look at all that work we did, right? All of those calculations, one problem. 3 pages of calculations for one problem. It's not going to be today. Going to have very much, which is good and bad. It's good because, yeah, you don't have to do all those calculations, right? No one likes to do all of those calculations, or very few people, I should say, like to do those calculations. That's great. But the part is either you know it or you don't know it, right? And you got, if you don't know it, you use your brain. A lot of people don't like it, okay? A lot of people are like, man, I can't think. Well, you got to train your brain how to think about it. Okay, most of you, all of you, to get class, you all have the capability. It's just, do you want to do it? That's the main thing. Okay, so read the example 1. Example 1. What does it tell you about the graph? What does it tell me about the graph? You don't need to do A or B. Just read number 1 and tell me, what do I know about this graph? What are the things I know that will help me with solving these questions? What are the things? Yeah, Isabel? That's the big thing right there. This graph isn't the original. This is not the original. Okay? This is the graph of the derivatives of the original. Okay? That's huge. The graph is the derivative of the originals. So this graph right here represents f prime. Okay? So this is a graph of f prime of x. It's not a graph of the original. So when I say a graph of f prime, what does that mean? A graph of f prime. How did I get it? I have to find the derivatives. Yeah. So what is each of those points? right now, I know you see the points. I'm talking about all the points. I know you see points here, points here, points here, but there's really points all over, right? There's an infinite number of points, right? That's what makes a segment. Where did we get all of those points from? What do they represent? What do they represent? One word. What do they represent? What do all of those points represent? Or you can use multiple one words, but really it just comes down to one word. What do all those points represent? Yes, yes, sir. There you go. They represent slopes of the original. Okay? So they don't give us the original graph. We don't have to draw the original graph. But on the original graph, when x was -4, what was the slope? So that point right there is, let me change the color, -4, 0, right? We know that. So at this point right here, what does that tell me about the original graph? F of x. What does that tell me about the original? If I had the picture of the original, what does that tell me? For this point here, 0, 0. Hmm? Yeah, why are they critical points? Yeah, Roman, why are they critical points? You're absolutely right. Why are they? He's right. Can anyone? Yeah. Keep going. You're right. You guys are right. Kind of put them together a little bit more. They're critical points. So if it's a critical point, what does that mean about the original? Think of a critical point value. When we found the critical points, why were they critical values? The Keep going. What about the tangent line? There you go. The derivative is 0, right? The derivative is 0. So what I know here is that at -4, when x is -4, for the original equation, the derivative was 0. The derivative was 0. I know that because that's why that point is there. Otherwise, that point would be there. Same thing with 0, right? At when x is 0 on the original, the derivative is 0. So do I know, again, those are critical points, right? Just like Roman said, absolutely. So that's going to answer our first question there. Our first question says, find the x coordinate of each critical point. Okay? So x equals, what did we say, -4, x equals 0, right? And here's the thing that a lot of you struggled with on the test. I graded some of them so far, and the ones that I graded struggled with this part right here. Justify your answer. That's why I put it on here, because I saw a lot of you guys are struggled with it. Some of you got it, but some of you struggled with it. I think you knew it up here, but when knowing it up here is not the same as putting it down here so someone else can understand it, right? Because sometimes when you guys know it up here, when you write it, you're like, oh, that makes sense to me. But then if you were to hand it to someone who doesn't do calculus, they'd be like, well, what does that mean, right? So you have to make it in so that they understand it. Okay, so why? So justification. Because why? So you guys said it, right? So let's put it into words and symbols. What were the reasons why we said those were going to have 0? Slopes of 0. Why are they critical points? Why did we say? You guys said it earlier. Why was that? Because right now that's a 2-point question, 2-point answer, right? This question would be worth 2 points, or 3 points, sorry, total. I would get 2 points because I got X's, right? I got 4, -4, and 0, right? I'd get 2 out of 3. I wouldn't get all 3. 2 out of 3 ain't bad if you want a 66%. And I don't think anyone in this class wants a 66% on their test. So how do I get the third point? Why are those critical points? The slope changes. It changes from what to what? You're right, it changes. So what does it change from? You're kind of up here, bring it down a little bit. You're kind of overshooting it, bring it down, make it a little bit easier on ourselves. You guys said it earlier. Why are those critical points? They're x-intercepts on the derivative. You're right. They're x-intercepts on the derivative. You guys are kind of dancing around it. You guys said it earlier. Why were these guys critical points? Because why? And what is why? Which is? Yeah, you guys see this was the issue on the test. A lot of you guys are saying stuff like that, like, that's right, y is 0. Y is 0. Okay, why does that matter? Right? Why does that matter? What is y? We said 0, right? Y was 0 for both of them. What does y represent? We said it earlier. What does y represent? What about the original equation? The slope, right? The slope. Because the slope is 0. Okay? Because something is equal to 0. What is equal to 0? How can we write that? I can write the slope of the original equation is 0. Or what can I use as symbols? The slope of the original equation. What can I use instead of the slope of the original equation? You guys have seen this symbol hundreds of times in this class, if not more. What symbol could we use instead? See, this is where that critical thinking hurts, because you got to think critically. F of x is the original. I don't want to put f of x because f of x represents the original. There you go. Done. This represents right here the derivative, right? This represents the derivative. What is the derivative equal to? 0. And I know what a lot of you are thinking. Oh, okay, I know that. Oh, yeah. Problem is you don't write that on your paper. And then on your paper, you write some gobbledygook that I don't understand. You understand it, but I don't understand it. And you get points marked off. And then you come up to me and say, Mr. Flores, that's what I wrote. And I'll be like, no, it doesn't make sense. Okay? This makes sense. F prime of x equals 0. That means the derivative equals 0. Okay? So that's what I mean. That's the kind of symbols I'm talking about. This is the kind of symbols I'm talking about here. When I say use symbols, when I wrote on the board on Friday, if you remember that far back, I said use words and symbols. That's what I meant. Okay? Tell me stuff about f prime. Because it's a word, f prime of x equals 0, that's a symbol. Okay? That's what I mean. Okay? A lot of you were drawing graphs. I had some people like drawing, oh, because this looks like that. I'm like, what? I'm like, just tell me that. Okay? If you want to tell me because the derivative is 0, that's how you tell me. Okay? So let's go to the next question. So these 2 points right here are either going to be what or what? They have 2 options. What are they going to be? A maximum or minimum, right? because that's where, that's where that's what happens at critical points, right? It's either a maximum or it's a minimum. Okay. How do we tell? How do we tell by the graph if it's a maximum or minimum? We've done this quite a few times, tens, if not more times, tens of maybe even hundreds of times. You guys have done this stuff. Problem is, you're looking at it from a different angle, and it looks different, but it's not. It's the same problem, right? Let's say I'm doing this problem here. I don't want to write it on here, but I'll write it on the board. Let's say I give you this equation here. And I asked you to tell me the relative extrema. Tell me the maximum minimums. All of you would know how to do it. How do I know that? Because you did it on the test. And most of you did it correctly. You're looking at the same problem. Problem is, you're looking at it from a different angle, right? And that's where that's where critical thinking comes in. Critical thinking is being able to look at something from a different angle and know, hey, that's the same problem, right? That's what critical thinking is, okay? A lot of people think this is critical thinking. No, this is not critical thinking. This is just calculations, right? You've been doing calculations forever, right? You don't really need to do anything critical. When you switch things up, anytime you change things up, that's critical thinking. So now we're changing things up here. This question, find the x coordinates of the relative extrema, you guys have done many, 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 many times. But I'm changing, now I'm saying, okay, don't look at it from this side, turn it around and look at it from this side. And a lot of you are like, it's the same type of problem, okay? So let's go through, how would I do this problem on the board? F of x equals 3x squared plus 4x minus 2. If I wanted to find relative extrema, how would I do that? How would I do that? Here, let's do this. The person that's closest to you, whether it's your elbow partner, whether it's someone next to you, tell them, how would you do this? I'll give you about 2 minutes. How would you do this problem? If I wanted to find relative extrema, maximum or minimums for the one that's on the board. Don't worry about the one that's on your notes right now. This one on the board. A little bit of review. How would I do that? Okay, go. Okay, sounds like you guys are done. What do we do? What's the first step? What's the first step? Mhm. Find the first derivative, set it equal to 0, right? Done. There are all the derivatives right there. That's done for you. Okay? Now, it looks different than you're used to seeing, and that's critical thinking. But this is the same thing, right? If I were to find the first derivative over here is going to be 6x plus 4. That's the first derivative over here, right? Set it equal to 0. Go from there, right? That's it right here. That's this. Okay? So what do I do after that? After I found the derivative, set it equal to 0, what do I do after that? Hmm? First derivative test, right? Good. First derivative test, right? We do this and that, find out if it's increasing or decreasing, right? How do we do that on this guy here? We're gonna do exactly this right here. How do we do that on that? There you go. Exactly. Aren't these points, aren't these on the first derivative test, right? When I did the first derivative test, right? And I did this and this, we knew these were 0, right? So I wanted to know what would happen before. What was happening before? What was happening afterwards, right? You want to know what's happening before the 0 and after critical points, right? Well, how can we use the graph here to do that? Just like Isabella said, find out what's happening before and what's happening afterwards. Okay, so let's look at the first dot right here. Negative 4, 0. What's the derivative before that? Positive or negative? You can't tell in my mask, but I'm smiling. The reason is because exactly half of you will say increasing, and exactly half of you will say decreasing, right? Which is it? And I know why half of you will say increasing and half of you will say decreasing. I know why. But it can only be one. It can't increase and decrease. It's only got to be one. So those of you that say some brave soul who says it's increasing before, it's going uphill. Raise your hand. Oh, nobody. How many people say it's decreasing before? Okay, so one of you brave souls that it says decreasing, tell me why you think it's negative before the derivative, before this point here. Yeah, you ready? Okay, so I start here and I go here. And what makes you say negative? Mhm. Oh, okay, I see what you're saying. Oh, so if we're going this way, it would be going uphill, right? But we always start from the left. Yeah. So we always start from the left, just like you, Raj, said. We always start from the left and go to the right. That's how we read graphs, right? Um, so wow, you guys. So not even there's not even a split. There's not even a 50-50 split. It's a whole 100%. So I knew this would happen, which is the reason why this is on there. A lot of you see that and think, oh, that's a negative slope. So it's negative beforehand. The answer is you're wrong. Now some people are saying, yeah, it's positive. Well, where were you guys beforehand? Right? Be brave. That's not negative. That's actually positive. What? Why? Exactly. Didn't we say 0 here? The y values, didn't we say earlier the y values were the derivatives? Right? A couple of you guys said that, right? You're looking at this like that's the original. That's not the original. That is not the original. If that was the original, absolutely. The derivative is negative here. 100%, no question about it. I would not argue with it. But you guys are looking at it like that's the original. No, that's not the original. That that is the derivative, right? And didn't we say the y values here were the derivatives of the original, right? We said that. So if I were to pick a point over here, the y value would be positive, right? Positive, 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 positive. The blue dot is where it switches, right? So if I were doing one of these guys here, so let me do it here. Let me write it over here. First derivative test, right? I got a -4 and I got a 0. This guy over here would be a big positive, positive, positive. One more time. Why is it positive? Because the y values are positive. And don't the y values, let's write that too. If you don't already have that, I see some of you guys writing it in, which is great. Y values represent slopes of the original. They represent slopes of the original, right? That's huge. This is not the original. On the next test, 100%, you can write it down right now. You're going to have a question like this. This is going to be the type of question you're going to have for your FRQ. Guarantee you. Okay? Because it's so huge. It's so important being able to read graphs. That's the main thing. You look at a graph and you think, oh, it's the original. No, it's the derivative. Okay? So it's positive before. All right? What about in between? -4 and 0. What's the derivative? Positive or negative? There you go. What are the y values? The y values are all negative. So we can put a big negatives there. And then what does it do afterwards, after 0? All the y values are positive, right? Until the end, until the very end of the interval. Why don't we include, why isn't 6 a critical value? There you go. Yeah, I skipped over that part. I meant to go over that earlier. Yeah, it's not there. If it said one of these, then absolutely include it. 100% include it, but it's not yet. Okay. Okay. So at -4, is it increasing or decreasing? At -4, is it increasing? Or sorry, increasing or decreasing? At -4, is it a maximum or minimum? Relative maximum or minimum at 4? It's going to be a maximum, right? Relative max at x equals 4. Here's the big part. Because how did we know without having to write long sentences, paragraphs? How can we cut it down to symbols? That explains how I know that that guy is going to be a maximum. How do you do that? Well, didn't this guy tell us why it was going to be a maximum? Right? This guy is the one that told us, right? So instead of long sentences, verbose sentences, which you use in English class, and those are great in English, but in math, not so much. How can we, in words, why is that a maximum? Because why? What's special here that tells us it's a maximum? Exactly. How can we write that in symbols? How can we write that in symbols? Because f prime changes from, what does it change from? Positive to negative. Good. Done. Mm-hmm. Yes. Thank you. Yep. Absolutely. Okay. So that's one of them. The other one, relative min at x equals 0. We know that's x equals 0 because, well, what about this guy right here tells us that at 0, it's going to be a minimum. What about this guy right here? It tells us it's going to be a minimum. Exactly. The only thing that's going to change in our justification is we're going to switch the negatives and the positives. F prime changes from negative to positive. Okay? That's justification Y. Okay? So anytime they ask you, why is this a maximum or minimum? It's always going to be because it changes from because the F prime changes from positive to negative. Always. It doesn't matter if they give you an equation like they did last chapter, or a graph this chapter, or a table. It don't matter. Okay? All right, so let's go down here. Increasing, decreasing. Intervals of increasing, decreasing. With justification. Increasing, decreasing. When we did this guy over here on the board, how did we tell if it was increasing or decreasing? Where did we look for increasing, decreasing? When we did that guy on the board, how did we tell if it was increasing or decreasing? What happened before the critical value? What happened after the critical value, right? We looked at this guy right here, right? We looked at this guy, right? We looked at this guy. So before 4, was it increasing or decreasing? Or sorry, before -4. Before -4. Before -4, was it increasing or decreasing? Because the derivative was positive, right? So increasing from negative infinity to -4. All right, let's write this down. Okay. From negative infinity to -4. Okay. And then in the middle, it was decreasing, right? From -4 to 0, decreasing. Okay. And let's finish it out. After 0, it was increasing again, right? So we use the symbol there, or. You can write the word in there, or, as well. Okay. So either of those are increasing. Okay. That's 2 points. We got our 2 points. Now we got to get the third point. The third point is justification. So how do I know that it was increasing at those 2 intervals? What led you to make that judgment? What led you to say, oh, it's increasing there and it's increasing there and there? What led me to that judgment? Exactly. And what were the y values again? Slopes. And what's another symbol for slopes? F prime of x, right? So f prime of x is, how do we write positive? How can I say positive? I can say is positive, or I can just say greater than 0, right? Same thing. Greater than 0 means it has to be a positive number. See, you guys are there. You guys are there. You guys know what you're doing. Just got to be able to express that so that that's negative, right? That's the thing about this lesson. It's everything you've done before, but you're just looking at it from a different angle. I'm shining a different light on it. Something you're like, I've never seen that. Yes, you have. Just didn't look the same, right? It didn't look the same, right? Have you guys seen those pictures before? Someone shows you a picture, and if you look at it the first time, you see one thing, and then if you look at it a different way, you see like an old lady. Have you guys seen those pictures? Like those pictures? Yeah, a lot of. It's the same thing. It's the same thing, right? The first time you look at it, you're looking at it one way with one perspective. Oh, okay, I see whatever. I think one of them's like a young lady. And then you sit there and look at it for a little bit longer and you're like, wait, I see an old lady too, kind of embedded in there, right? It's the same thing. You're looking at it from a different perspective. And that's exactly what this is here. Okay. So points of inflection, points of inflection. Okay. How did I do points of inflection last chapter? Second derivative. Good. Second derivative. So to do a second derivative, right? That's pretty easy for this question on the board, right? Find the derivative again. I don't have that though. I don't have an equation. I just have a graph. So how can I find the second derivative here? What is this graph representing it? It's always good to tell yourself, what is this graph represent again? It represents graph of f prime, right? And if I want to know the derivatives, that's the y values, right? We said that. Now I want to know this. So how am I going to find f double prime? Not the x values. X values are always going to stay the same. So the derivatives are already there. How do I find the second derivative? You guys have done this before. Okay, so let's do this again. Look at it through a different lens. Again, different perspective. Steps to find derivatives. I would take this guy up here and find the derivative, right? I need to do the same thing over there. Find the derivative. How do I do that? How do I find the derivatives of this guy? What does derivatives represent? So now what I'm trying to do is trying to find the derivatives of the derivative, right? The y values were the derivatives of the original, which I didn't have. Now what I'm trying to do is find the derivatives of that guy right there that you're looking at. So how do I find the derivatives of that guy? This is what you guys tried to do earlier, but it was wrong then, but it's going to be right now. How do I find the derivatives of this guy here? Give you a hint. Mm-hmm.
Can I just use where the derivative would be 0? Like would an inflection point be at -2, -2?
-2. Yes, it would be. How do you know that? You're right. That's true. Yeah. This is going to be an inflection point right here. -2 at x equals -2. That's going to be an inflection point. That's correct. What led you to say that? And what is the derivative at -2? 0. Yeah, it's just a tangent line, right? It's just a tangent line. He's just finding the derivative of this guy here. So remember back about 10, 15 minutes ago when you guys said, oh, this is negative here, right? The derivative is negative here. And I was like, no. The y values are positive, so it's positive. Well, now we're going to do that, which you guys wanted to do. So the derivative here is negative, right? So we're finding the derivatives of this guy here, right? We're finding the derivatives of this guy here. So we want to find where f double prime is 0. That'll be the points of inflection. Sebastian was right. One spot is going to be right here at -2. Why at -2? Because isn't the derivative at -2 for the derivative of the derivative, right, is 0. Right? So let's write that down. X equals -2. The derivative of the derivative is 0. Where else would that be true? Is the derivative here 0? That line right there, does that have a slope of 0? Nope. It has a slope of negative something. So nope, I don't want that. This right here, the slope is still negative. Here we said earlier, right? Here we said that's where it's 0. Is it going to be 0 anywhere else? So yeah, this point here, you're going to have a 0, not necessarily a 0, but it's going to be undefined, right? Because this is a corner, right? Didn't we say at corners, the slope is 0? Okay. So also at +4. So why again? Tell me again, why are those? Because why are those inflection points? Exactly. F double prime is 0 for -2. Absolutely. That would work for -2. How do I write it for 0 though? Or sorry, not 0, 4. Because it wasn't 0 there, right? What happens at 4? What happens to the derivative there that leads me to say that it's a point of inflection? What happens to the derivative? Watch my pen. Positive, negative derivative. It's going uphill, right? Positive. Positive, negative derivative. Negative, it's going downhill. What happened in between? Same thing that happened here, right? Negative, derivative, negative, 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 negative. And then what happens afterwards? It goes up. So if we only had -2, I would say double prime is 0, absolutely. But this is not 0. This is it's a corner. So we would say, more accurately, we would say because F double prime changes signs. F double prime changes signs. Okay? Because it changes signs, it has to be, same thing up here. Same thing with the first derivative, right? It was positive here, and then did it change to negative? And then it changed to positive? That's the same thing, right? That's the hardest thing when you're flipping in between first derivative, second derivative, the original with the same graph. I don't want to say it's difficult because it's just, you really have to engage yourself in it because otherwise you're going to confuse the heck out of yourself. Okay, so you really have to be engaged. So if you're only catching like every other thing, it's going to be super confusing on this. Okay, you really have to engage yourself on this. We're going to finish this tomorrow, but That's the idea of it, guys. That's the idea. I'm not going to ask for anything harder than these questions I have here. Okay? The only thing other is concave up, concave down. Well, if you can do inflection points, concave up, concave down is not that bad. Okay? But I'm telling you right now, write it down, guarantee you. When we take that last chapter test in a few weeks, right before the final, this will be your free response question. This will be your free response question. The graph is going to be different. It won't be this graph, but it'll be something similar. And I'm going to ask you these types of questions. Where's the relative maximum? Where's the relative minimum? How do you know? Where's the points of inflection? How do you know? All of that stuff. I'm telling you right now. Okay? So if you want to do well on it, make sure you study up on this. Okay? We'll finish this on tomorrow. Okay?